Hello guys and welcome to another episode of How Computer Works, and maybe this is episode number 13 and we'll be looking at the other half of the computers. But let's first clear off another topic, and that is about the RAM, and we have talked about how RAM works in the previous video, so I'll just clear off thing some things that may be confusing. The MARS is the memory address register. This memory address register is just as we have a RAM of 256 bits. It has address from 0 to 255, which is still 256 bytes, and this memory address register just selects one of those 256 bytes. So in computer, byte actually does not have any identifying info, but it is simply the byte in memory which is get selected by MAR. So in a temporary memory, this is only the the byte that the computer is asking for, and that will be selected is how actually the memory works. And now that's all what I have to clear you off. And now we'll talk about the other half of the computer. One half is the memory, which I have just built using different NAND gates in the previous video, and the other half consists of NAND gate and is not is actually not like the RAM. It's more hard to explain, and this is called the CPU, or central processing unit. Is just what processes the byte, or actually calculates byte from two calculates different byte to produce a meaningful result using, well, as we know, logic gates. And that is what we also have the other half of the computer is. And we have CPU, and we'll see how CPU works. So before that, let's just see some new gates which are actually not at all different. We just combine the previous gates we have learned to form some new combinations. So there is one called the OR gate. Maybe you've heard of this one, but let me again explain to you guys. uh, this is the NOT gate, as we have learned from before, and here is a big NAND gate with another NOT sign in it, and last is this one. So this is the output C, and as always we'll make a table about the different combinations. If both are 0, C will be 0. If both are if one of them is 1, then we will have an 1. And also for this one, if this one is 1, we'll still have C as 1. And also, as you have guessed, if both of them are actually 1, if A and B is both 1A, B is both 1C, will also be 1. So this is an OR gate. We call it an OR gate. It produces a true result, mean bit of 1, if both of them are 1. If any one of them are on 1, then it produces a 1, unless if both of them are 0, it will produce a 0. So that goes OR gate. We have another special one which is same as this previous one, but it works a little bit differently, and that is actually not so complicated. So again we have the two B's, we have the wires coming out, like this. Sorry for the delay in my drawing, but as you have know, we have to see how it is drawn to understand how each. Sorry, I have made a mistake. It goes like this. and then this part goes like this, and we have a intersection here. This will go to a NOT gate, and this one will also go to a NOT gate, and then follows by a wire, and also a wire here, and we have a NAND gate around here, and same for this part. We have a NAND gate over here, and then these two goes to another NAND gate, and we have gotten the output C. So let me just say what kind of, this is an XOR gate. This is like an OR gate, but it will only be true if both of them are different, and if both of them are A and B are same, then it will be producing a 0 or a false. Let me again show you the truth table. So 0 0, then 0, then 1, then 1, then 0, then 1 and 1. So if both of them are 0 0, then this will be 0 because A and B are both the same bit. But if one of them is 1 and another one is 0, then produce a 1. If again this A is 1 and B is 0, then as they are different, we produce a 1. But if both of them are 1, then we again get a 0. Sorry for all the messy writing, but I think you get the idea. And that is XOR gate. This is a very useful gate, and we'll see how it works in the future videos. So that's all for today. We'll be learning about more how different combination of logic gate, and that's actually what a computer consists of. So that's all for today, and thanks for watching, and hope you stay tuned for the next video. If you want to learn more about how computer works, you can read this book called But How Do It Know, written by Clark Scott. All of this material I have been using is actually taking help from this wonderful book written by Clark Scott about how actually a computer works, and it is for everyone, so everyone will be able to understand the simple language. And I have been using some of this content. However, some of the content are copyrighted by Clark Scott by himself, but I have been given permission to use it. So anyways, if you want to learn more about how computer works, you can check this simple written book, But How Do It Know.